they talked about this, red, green, and blue. So when you have red, green, and blue light, you make all of the colors that we see. Does that mean that there is no such thing as yellow? It's just a mixture of red and green. The answer is no. There is, of course, yellow light. There's all different colors of light because, remember, the spectrum is continuous. So we've got the long wavelengths down here, like the red, and then, you know, the orange, and then the yellow, and then the green, and so on, all the way to where we get in violet and ultraviolet, and all that we can't see, and then infrared down there. So all of the colors exist, but we don't see all of the colors. As the person pointed out, we only have 3 different types of cone cells, red, green, blue. So if we're to see something like yellow, even though there is a color yellow, the reason we see it is because it's enough like the red and enough like the green that both of those cells are firing and sending signals to our brain, and our brain puts them together and creates yellow for us. Okay? But that also means that if we triggered the red and the green separately, they would be sending the same signals, and we would see yellow. And that's the way this projector up here, for instance, is working. This projector has 3 colors, red, green, and blue, and that's it. So how does it project yellow? Well, it's projecting red and it's projecting green. And that triggers our eyes, the red cone cells and the green cone cells, and when they send the same signal to our brain at the same time, our brain sees yellow, just as it would if a yellow light was making the red and the green go at the same time. Okay? So, now these colors are called additive. Okay? And you may have heard RGB before, particularly in computer terms. Used to be an RGB monitor, red, green, blue, could produce all of the colors. All right? But if you take an art class, what you're going to find out is, or you're going to hear people say, well, red, green, blue, those aren't the primary colors. They're part right. The primary colors really are red, green, and blue, because those are the colors that our cone cells see. But most of the time, somebody who's taking art not from a scientific perspective thinks of the primary colors as being the colors of their paints. And paint is not additive. Paint is subtractive. So for instance, this cyan color of paint isn't the combination of blue and green. If I mix blue and green, I get some kind of muddy brown probably. Okay? What cyan is a paint that absorbs all the colors of light and reflects back blue and green and absorbs red. Okay? So this color of paint is something that absorbs the red, and this is what's left behind. So paints are subtractive colors. And so, for instance, cyan, magenta, and yellow, subtracting colors from there allows you to produce all the different colors. That's the reason why if I come over to my printer, this big color printer over here that I rarely ever use, cyan, magenta, and yellow are the 3 primary pigments. So this is light, and this over here is pigment. So, in essence, there really are more than one set of primary colors. In physics, we're almost always talking about the colors of the actual light, like projected light, or the kind of light you would get if you took a prism and split it into multiple colors. Okay? For those, the primary colors are red, green, and blue. And by mixing the combination of how much of each of those there are, we can produce any color that our eyes can see, because those are the only things that our eyes can see, red, green, and blue. Okay? And everything else is just a mixture of those 3 things firing at different amounts. Okay? But there are different types of subtractive colors. Okay? In these cyan, magenta, and yellow, which is the most common for instance, photography or color or something like that. This is how you mix the colors, by removing a color of reflected light. There's also another common RYB. So in this case, it's red, yellow, blue, subtractive colors. And if you want to get really technical, you can look at things like the color triangle, where we have different colors, and we pick spots along this line, and if we have things along this line, we can mix colors to create anything that we want to see. This is how they do it at the paint store when you're buying color, and you bring in that little chip of colored paint and compare it and everything, and then they say, okay, you can mix that color. They're using a computer so that humans don't have to do it. Is they're probably reading a code number off of there which tells them how much of these pigments to put in. But basically, if I want a color over here, what I have to do is I have to start with some color over here, and some color over here, and some color up there, and I can get that color. But I can start with other colors. I can start with other colors and still get the same thing and mix them the right way. I didn't draw those lines correctly, but I can still get the same colors. In reality, it's not a color triangle. It's actually more like a wavy thing, because our eyes are sensitive to different colors in different amounts. So for instance, we see things that are like yellow and green much better than things that are violet. Our eyes aren't as sensitive to those colors. But you can see how that's roughly a triangle, right? So we often just call it the color triangle. But this is more of an art concept. When we talk about physics colors and physics lights, we're almost always talking about this, which is the additive actual light spectrum, which is RGB, red, green, and blue, because those are the cone cells that are in our eyes. Okay? Are there any questions about these? In this way, if you hear somebody like in an art class who's talking about, oh, red, green, and blue are not the primary colors. No, I take art. I've had 4 years of art, and I've had AP Art 1, AP Art 2, AP Art 3, and red, green, and blue are not primary colors. Calm down. It's okay. There are other different ways to look at color. We're talking about it from a physics standpoint of additive light, and most artists are talking about it subtractive pigments. Pigments remove color from the reflected light. We're talking about adding color to projected light. So it's okay that there's more than one set of primary colors. But these are the ones we talk about in here for the most part, unless we want to get into the science of art and the science of pigments and the science of paints and colors and things like that, which we can also do. But really in this class, we're mostly going to talk like this. All right? Okay, very good.